All right, so hi everyone. I'm Joel, and I'm a co-founder of 3Box Labs. And I thought, so I'm gonna the main thing I'm gonna be talking about is ceramic because that's like the protocol that we're building. Um, but I thought I'd start with like some history of like where we're coming from, what 3Box is, and how that's kind of evolving. Um, so actually, let's kind of throw back to kind of early days in Ethereum, and um, back in 20, I guess around the summer of 2016, the there was a project called Uport, and it was really focused on like identities in Web3 and had like a mobile app which you could use as a wallet and also have like verifiable credentials and stuff. And I was actually part of the team that was working on Newport. Um, and but however, like Uport was its own app, and everyone was kind of using MetaMask or some other Ethereum wallet. And it was kind of like you kind of had to like either you had like this app with like a profile and stuff, or you just had like the other Ethereum wallets that everyone used. So me and my co-founders were part of the Uport team and kind of saw that, okay, this is not right. Maybe we can do something differently. And that's eventually we saw that, yeah, let's create a new thing that can be used by all wallets and that lets any wallet kind of associate arbitrary data to like an Ethereum address. And yeah, so we created 3Box. So 3Box is an SDK that developers can pull into their app and like store data that's linked to their Ethereum address. And this is like based on some standards that we were part of like creating in Newport, primarily called DIDs. However, 3Box.js, well, actually, so yeah, so the first kind of application of 3Box became like profiles because like everyone used like had these Ethereum addresses, those random numbers and characters, and the first thing you would do with like arbitrary data associated with an Ethereum address is just like add a name, add an image, and then yeah, just build out a profile about like your account so you can like interact with other users in a more human way. So we created this 3Box Hub app which allowed you to like create profiles and like view stuff associated with your profile. And I think it was like the first user-centric NFT gallery, which was just like a random feature we threw in, and we haven't really focused on that at all. But there were some like pieces of 3Box that were centralized, so the link between your Ethereum address and your DID that relied on a central server, and the data storage system was kind of it was decentralized, but it kind of assumed that you would be connected to like the 3Box servers. So obviously, like we knew this was like a trade-off when we made these like implementations, but we realized, yeah, we're gonna have to like really decentralize those things at some point. And it was like a bit like over a year ago that we started really thinking about like how do we actually like really decentralize the entire system. And we started thinking like primarily focused on this link between like addresses and DIDs, and then like making DID secure so you can like update the private and public keys that you use with them. So as we were like ideating, we found out like a way to do it, and then we started like, maybe this thing can be made a lot more like general, and eventually that led to the creation of Ceramic. So Ceramic is like a distributed network for version controlled data, where I can create what we call a document and then make updates to that document. And then you can see the kind of version history of that document. And that's useful for like profiles, but it also has like a lot of other use cases that I'll kind of discuss a bit later. And yes, this kind of also allowed us to make the new version, or like the decentralized version of 3Box, JS, which we now are calling IDX. And it's that kind of becomes like a blockchain agnostic version of 3box, which you can use with Ethereum, but you can also use with Polkadot or some other blockchain, and you can kind of link accounts that you have on different blockchains or on like layer 2s to the same identifier, so you can have the same profile regardless of like which app you're using and like which blockchain that application is on. All right, so that was a bit of history and like what we've been doing and like so like how we came to Ceramic. So let's dive into what Ceramic is. As I mentioned, it's a protocol for kind of version control data, and the unit like the primitive in Ceramic is a document. So document is really a data object that you create, and this document has like a permanent identifier, which we call the doc ID. And the document is created and it's signed by the user, but you can also change the document. And as you change the document, it still persists and have the same identifier, which is different from in IPFS. Like in IPFS, if you change data, you always get like a new hash of the data. In Ceramic, keep the same identifier, and we build like a doc chain or like an append-only log of objects in IPFS that represents the changes of the document over time. But yeah, we have this permalink to the document, and now we can start doing things like linking documents to each other, so we can create a graph of documents. I'll kind of talk about how that can be used a little bit later. But yeah, we can create this graph of documents that like point to each other, so we can like start building out like different types of web of trusts, or like underlying data for reputation systems, and the kind of stuff like that. And like this is a decentralized network, and that kind of makes it censorship resistant, which is useful in some cases. And another cool thing is like these documents you mostly like put JSON data in it, but you can also store a JSON schema, and then you can use a JSON schema that's stored as a Ceramic document as like a schema that's enforced on the document. So you can make sure that certain documents conform to certain schemas or like formulas, so you know exactly what data you will be getting out of Ceramic. And other than just like updating documents are also anchored into blockchains, and primarily anchored into Ethereum. And this gives us kind of like partly it's like a proof of existence that this document actually existed at this point in time, and we can prove that it existed at that point in time and it was not just like randomly created later. Which is useful for when you're doing like key rotation, but also like useful if you want like to have like an auditable trail of like updated of like events that have happened. And so all these documents like are controlled by DAIDs, which is a standard for decentralized identifiers. And in 3box, we have this DAD called 3ID. This 3ID will keep working with Ceramic. We also recently published a spec for something called an NFT DAD method, and this basically like a way to represent an identity using an NFT. So what it does is takes all the NFTs that exist right now, and saying basically that the owner of this NFT is the controller of this identity. So you can have like an identity that I can trade using an NFT, and that NFT or like the NFT identity can have like a bunch of data that is associated with it and like lives publicly on the Ceramic network. So yeah, that's something like we're excited about, like those types of kind of random use cases for this stuff. All right, so this is kind of like a kind of conceptual view of like what the Ceramic network looks like. So when you create a document in Ceramic, we don't have a global state like Ethereum, where like there's like one truth of like what the state of all smart contracts is. Instead, each document in Ceramic is kind of independently verified. And so we can see here 4 nodes, And some documents are pinned on some nodes, some documents are pinned on other nodes, and there's some overlap where some documents are pinned by multiple nodes. So these nodes kind of just keep track of the data and the documents that they care about. And all of the updates are kind of gossiped over libPDP, which is like the peer-to-peer protocol used by like Ethereum and IPFS and Filecoin and stuff. Yeah, the data logs are synced using IPFS. And yeah, libPDP and PubSub is used to like gossip, like what if I come into the network and I have a document ID, I can find out like what the latest state of the document is. All right, and yeah, so there's no like data persistence built into the protocol yet, so you have to like either run a node or have someone else run a node to pin documents for you. This might be changed with like incentives in the future, where you can just pay the network to keep track of documents for you. All right, so let's jump even deeper. So what does a ceramic document, like the actual data structure, look like? So a document in ceramic is essentially this log or stream of commits. And so here you can see a document which has like, let's see, like 6 different commits. So we have the Genesis commit, that's like the commit that creates a document. And also the hash of the Genesis commit is used as, with some other information, is used as the document ID. Then we can see there's an anchor commit that basically like anchors the document into the blockchain. Then there's a signature commit. The signature usually contains like a patch that changes the content of the document. And there's another signature commit, so that the document was like updated again. And then there's another anchor commit, which means like, yeah, it was anchored into the blockchain again. So every time we do like an anchor, we get like a timestamp of like, yeah, this was the state of document at this point in time. Yeah, and then lastly, there's another signature commit, and this kind of can go on for however long. The cool thing about the anchors here is that obviously you could like make one blockchain transaction per anchor, but that would be like very expensive, like if you have a lot of documents. So instead, in practice, what we're doing is there can be like one or multiple anchor services. And what an anchor service does is it takes like updates from a bunch of different documents and put them into like a large Merkle tree. And then it makes one transaction on Ethereum and puts just the root of the Merkle tree on chain. And now this proof metadata contains like something that says like, hey, this is the path in the Merkle tree that's used to prove that this document was anchored on this blockchain transaction. An interesting thing to note here is like, if there is a conflict, so like let's say this stream of commits like branches, and now there's like 2 competing logs or like competing histories. Which one should we choose? Like which one would be the canonical one? And that's right now we have a pretty simple thing to decide that, and that's essentially like the log that was anchored earlier wins. So if there's 2 competing ones, if log A was anchored at like 5 minutes ago, and log B was anchored like 4 minutes ago, log A will win because it was anchored earlier. And that's kind of how we decide like the consensus of like which is the canonical branch of the document. And each commit also has like its own what we call a commit ID, and this can be used to refer to this document at this point in time. So like if I want to know like what the state was here, I can just get the commit ID here and load the document at this specific point in time. All right, so that should give you a pretty in-depth view of like what kind of like a ceramic document really is. So I'm going to talk about like a few building blocks that kind of makes this possible. That we've been working on with ceramic and kind of standardizing some of these kind of lower level building blocks. So IPFS in general is really good for storing data, like using data blobs, but if you want to store signed data, right now people are kind of storing signed data in a bunch of different ways, and also like encrypted data. There isn't really any standard to do that. That is until we introduced this new codec in IPFS called DAG Jose. So Jose is like a standard from the Internet Engineering Task Force, IETF, and yeah, that's really kind of a standard way of like encoding a JSON object that's been signed or encrypted, and we have built like a compatibility layer for IPFS that allows you to put this this formatted data into IPFS directly and like have that be easily interpretable in IPFS. So we are adopting this standard in Ceramic. There are other IPFS, projects in IPFS that are also looking at this and like starting to use it as well. Then we have created an EIP for something we call a DID provider. And that's essentially a way to like request signatures from a decentralized identifier or request a DID to decrypt some data. And this can be added to like using to the Ethereum JSON RPC or really kind of any wallet JSON RPC to support these DID methods. And we use this in one of our kind of wallet compatibility layers that we've created, which I'll talk about a little bit more later, called 380 Connect. And on this kind of lower level, we have support for encryption. So that's using JWE, JSON Web Encryption. That's part of this or like the Jose stack, which I talked about just before. And this uses a cipher called XChaCha 20 poly 1305. It's a mouthful, but it's really kind of the latest encryption cipher that's also used in TLS. So kind of the thing that encrypts all of your HTTPS browser sessions. Yeah, and I mean then we also have like a library called JSDID, which is just like a way to consume and interact with the DID and uses so kind of all of these three other primitives. So yeah, you can create these DAG Jose objects and like put them into IPFS easily. So if you want to like play around with this lower level building blocks, like JSDID is a good place to start. And the Ceramic bundle kind of comes with JSDID instance by default. All right, so let's zoom out a bit. Like, what can we actually build with Ceramic? So I'm just going to mention really quickly some stuff that I'm like excited about because I think there are some of the cool use cases that we can do. So yeah, I guess the first thing is like discussions. There are already a few teams that are building discussions on top of Ceramic, and this is like especially good for when like you're doing governance of like a decentralized protocol and you have a DAO and you want to have discussions, because you get versioning of the discussion, you get the discussions get anchored on chain, so you can kind of have a lot of transparency because you can see that, okay, this comment happened at this point in time, and if there's like some large dispute, you can always like refer to this and like know that no one has like if you have a forum that someone controls, someone could like really kind of go and edit the comments in the database or whatever. That's not really possible with Ceramic. So you can kind of trust in comments that were made, and you can like verify that that's actually what happened. Using the same property, we can also build voting systems. So yeah, this could be like a simple, coin-weighted voting system like Snapshot, where every vote would be recorded into Ceramic. But you can also build like more complicated voting systems like conviction voting. So conviction voting is essentially a way to vote where you signal with your tokens, and the longer you signal on a specific proposal or a specific entry in like a curation game or something, the more weights you get. And that's based on like your token holdings. But like if you signal longer, then your signal that your tokens provide will be like worth more. Yeah, and yeah, that's kind of it's really cool because you can make certain proposals pass without having like a global consensus of all the token holders. Quadratic voting is also interesting, and it can actually be combined with conviction voting, which I think is some projects have like started to explore this, but it's still kind of very new concept. And quadratic voting also requires some kind of identity, thing where you can like say that if, basically you need some kind of stronger identity for the quadratic voting to be like feasible. Otherwise, someone could just like Sybil attack it. But the cool thing is, I guess I'll jump to the right here on the slides, is identity index. So IDX, or identity index, is really kind of the next version of 3box.js. And it allows you to associate a bunch of profiles like reputation or verify social accounts and point that to your blockchain account, or point that to like 2 of your blockchain accounts, or your blockchain account on Ethereum, your layer 2 account, and your account on like Polkadot. So you can kind of really kind of bind a lot of information to a profile or like an pseudonym in like a trustless way. And that's really useful, especially if you want to build up some kind of score that makes it less likely for this, identity to be a Sybil, which is useful in quadratic voting, for example. So yeah, I'm going to talk more about IDX and how it works, but just kind of mention that quadratic voting, quadratic conviction voting is something that's like seems really exciting to me. In general, also like Ceramic is useful for like when you have different types of dispute resolutions, because like since the document have this audit trail or like commit log of changes, you get this audit trail that's useful. If there's a dispute, you can always like look up what's happened. It's also good for like publication. Like if you're doing research and you want to publicize something, you want to be known that you publicized it, then like Ceramic provides a timestamp that's anchored in the blockchain, which gives you, that a proof that this paper that you published was actually existed at this point in time. Like it also used for like journalism for the same reason, and OSINT, open source intelligence, for the same reason, because you get this kind of certainty around like when it was published, who was published by, like the signatures are encoded in the data structure. All right. And so Ceramic, the protocol, the development is being led by 3box, but it's really kind of just an open source community. We have like several contributors already. Our DAD method, the 3AD method, is actually being implemented in Go by another team, which is super cool. Textile. So they're building compatibility with like the Ceramic ecosystem. And you can really kind of think of Ceramic as like the shared metadata layer for Web3. So you can kind of connect different blockchains or like Wix and blockchains account to your identity, and connect your identity to like different peer-to-peer databases, and really kind of bring all of Web3 together. IDX I already mentioned a little bit, I'll kind of dive into the specific bullets here in the next slide. We have a testnet that's like up and running. You can check out the CLI tool, and you can also run this in your browser. All the code is like available on GitHub, Ceramic network, and the main repo is this JS Ceramic monorepo. All right, so let's chat about IDX. IDX is like really simple. It's just a data structure on top of Ceramic, kind of using the documents to create a structure for user data. And there's like 3 different concepts that are useful here. So we have the index, that each user have their own index, and it's just like an index, is key value mapping from a definition to records. So a record is a discrete unit of like user information. This record can be used to store content directly, or it can store a pointer, like a reference to some remote resource. Like I have some data that lives on the centralized server, or it lives on this other peer-to-peer database like Core BTB or Textile. And then we have definitions. So definition is created by a developer and describes the content that lives within the record. And it actually describes that with the JSON schema, so you actually always know exactly the semantic structure of the data that you can find in the record. Yeah, so I don't know if you can see my cursor, but in this image to the right, we can see that. So this definition to the left here in the image is created by the developer. And we have two users, user one, this astronaut, and this magician mage here. And they all each have their own kind of index, but their index kind of have the definition, and that they use the same definition. And I think this is just the basic profile. And then they have their own, so they have the same definition, but they have their own record. So you can see like here is a name and an emoji. This user one has like a name and a different emoji. So yeah, that's kind of the model. And the cool thing here is like me as a developer, I might want to like build a new cool app, and I can use browse the definitions that have been created by developers before, and just like start pulling in data from existing applications into my application. So we kind of get like composability of user data. Yeah, so that's really cool. And the API for IDX is like super straightforward. You basically have a definition ID, and then you can get the information, get the record using calling IDX.get, definition and the ID of the user. And the same way you can set information, but if the user is authenticated, it's calling IDX.set, the definition ID and the content that you want the record to be set to. One thing I wanted to mention also, when you're building with IDX and you want to connect it to a user's MetaMask or some other wallet, 380 Connect is like a tool that makes the connection between your user's wallet and their IDX and the ID profiles. So like 380 Connect is basically a way to authenticate and like write documents to Ceramic. And it can be used with like any blockchain wallets. Right now, it works best with Ethereum wallets, but it can really, we have like modules to make it work with like EOS, Filecoin, Near, and like other types of blockchains. So we can really kind of start connecting all the different kind of separate pieces in the Web3 ecosystem. And it supports this EIP 2844, which I talked about earlier, which is this DID provider, an interface for like requesting signatures from a DID, and decrypting data. And yeah, so the cool thing about 380 Connect also is that we can have multiple blockchain accounts that authenticate to the same 380. So let's say I have my, my Filecoin account and my Ethereum account, and they both authenticate and link to the same identity, and that this is enabled through 3ID and the kind of key management that we do in there. So yeah, the 380 DID method, I guess, yeah, so multiple authentication methods, a key chain that allows for this secure key revocation that makes this kind of multi-account thing possible. All right, and lastly, I was going to give a teaser. So 3box has always like had a profile site, and this is like hasn't been updated in a long while. And the reason for that is we have been working on the Ceramic protocol, but there is a new profile site coming soon. It's going to be pretty cool. It's based on IDX, and it's just super simple. You allow us to like edit your profile and just look up a profile for any like address or like account on any blockchain. So you can just put that in there and like find the profile. The other thing that will be part of this is something called identity link services, and this is just a way to like verify your social accounts and put them into your IDX, so you can kind of build some reputation into your profile. So identity link services right now is just like a simple Web2 API that issues like a verifiable credential about your DID is associated with Web2 accounts. So this right now it has support for GitHub, Twitter, Discord, Discourse, and there is one or actually maybe two PRs because there's a Gitcoin hackathon to add Telegram. So this is cool because then we can kind of start building out the graph of like your accounts. All right. Well, that was a lot of information. I hope you found like pieces of this presentation useful. Really excited about like finding what type of stuff can be built on Ceramic, like once we have these basic primitives like profiles and stuff. So yeah, thanks for having me on.